Hey, this is Dan from userspice.com, and I thought I would do a different kind of video today. I want to look through some concepts around storing passwords in PHP, or more specifically in bcrypt. We're going to do a little bit of unscientific testing. I'm not going to pretend like this is in a lab and that we're writing a thoughtful article, but I just want to give you guys some ideas. So basically, what I've done here is I wrote a password of 5,000. And as I go through this video, I'm going to try to walk the line between giving you some good information and some understanding without trying to make your head spin too much. And I picked 5,000 for a specific reason. So let's assume that you were allowed to pick any password between 0, 0, 0, 0, 0, and 9999, something like that. If you think about the idea of just straight up brute forcing, going through 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, like that, on average, you're going to hit half the passwords below 5,000 and half the passwords are going to be above 5,000. This is just assuming that you're just going straight through. So the reason why I picked 5,000 is because it's about right in the middle of, if you were trying to cycle through the numbers, on average, this is how long it would take you to get it. I hope that makes sense. So if you were to pick a random number in here, half of them would be above 5,000, half of them were to be below. I picked 5,000 because it's going to give you a good average. And the first thing I want you to see is, in the old days when I first started writing PHP, it wasn't uncommon for people to either store the passwords in plain text in the database, or to do something really basic like MD5. And at most what they might do is, this is called a hash, which is basically mixing it up for simplicity's sake. If you were super strong, you would do something called hashing and salting, and you would mix a little bit of other information in there to kind of obfuscate what's going on. But what I'm going to do is, and I'm going to change this to 5, and there's a reason for this. What I'm going to do is I'm going to take this password of 5,000 and I'm going to test it, and I'm going to encrypt it, quote unquote, encrypt it twice with MD5 and encrypt it twice with bcrypt, which is the built-in password storage hashing thing that PHP has, and we're going to just echo out the results. So I'm going to save that, and I'm going to go to my index. I'm using UserSpice, but you can do this in vanilla PHP. So you can see here, one of the interesting things is that the two MD5 passwords are exactly the same, and the bcrypt passwords are different. And so if you think about it, you might look on first glance, you might say, wow, it turned 5,000 into this. It's a mix of lowercase letters and numbers. That looks really secure. It looks really jumbled up. But the idea that these are the same, and every single time I were to hash this, I'm going to get the same results here, which means that what you can do is you can basically do a cross-reference table. So you can take all the common passwords and kind of quote-unquote, encrypt them with MD5, and all you have to do is look up to see what this password is in MD5, and you know that that's 5,000, and every single time that's going to be 5,000. So that's why things like MD5 are a bad idea. Now we have this one, and you can see there's a mix of capital letters and lowercase numbers. You do notice that they both begin with this, and so this is kind of interesting, and you'll see a little bit more why later. But the idea is that this is just basically telling you that this is a bcrypt password, but this next thing, the 05 part of it, comes from right here, and the idea of a cost is really important. So I'm gonna try to keep it really simple, but there's a lot of different types of encryption, and the different types of encryption have better strengths and weaknesses. And in this case, you want something that's actually deliberately slow. If you were encrypting your hard drive or some kind of big piece of information, you might want it to be the fastest, best, strongest encryption. But in this case, what you want is a relatively short thing to store in the database. You don't want to store something that's 6 pages of encrypted text to store a password of 5,000. So you want something that's relatively short. You want something that is not what they call deterministic. And what this means is that every time we go through this, we're going to get the same thing. You don't want this to be deterministic to where somebody can just keep a cross-reference table of, what all these passwords are. And the last thing you want is for it to be deliberately slow. And that's kind of what we're going to be talking about today. We're going to talk about the idea of brute forcing these passwords and kind of scrolling through there. And the reason why I chose a cost of 5 actually goes back a long time when these encryption algorithms are tested. Just from way back in the day, they've always used a cost of 5 as kind of the thing that's sort of the official one. Now that's a terrible idea, and you're going to see why in a second. And so what we're going to do, we're going to comment all this out, and I have pre-encrypted this password at a strength of 5 and put it right here, and I've pre-encrypted it at a strength of 12, which is, I believe, what UserSpice uses. And so we're going to comment all this out. We're going to keep the password still at 5,000 just so it's there. And you can see what I did here is I did a password hash here, and then I just copied it off the screen and put it in here. So what we're going to do is we're going to look real quick at going through and how long it will take to brute force this. So let me refresh the page. Refresh again. All right, so we're at 100. Let's just say 100 milliseconds. So we're gonna. There's some overhead here because we're using a plugin to determine how much. But we're just gonna assume on average 100 milliseconds ish. If you refresh the page. So we have this password already stored here. This is the encrypted version. Now, one of the things that's really important to know is that I am not storing this in the database. So if we were in the database, this would be slower than it is, but we're going to assume that somebody stole your database and they're sitting here on their computer, and I'm using an 8-core 16-thread CPU, and I'm just going to mash on these passwords and see how fast I can decrypt them. So if I were to come in here and look at this first one, what I'm going to do, you'll notice I'm using PW, which is, I'm just going straight for it. This is unencrypted. So if you had stored your password in there, what I'm going to do is I'm going to loop through, and I'm going to go from 0 to 1,000, and I'm going to check the password. And when I get to the password, I'm going to break out of the thing, and then we're going to see how long it took to do that. So I'm going to save this. It's saved. I'm going to refresh the page, and I'm going to see that basically in 35 milliseconds, I'll refresh it again. I mean, one of those was even faster. So you're talking zero impact on the page to loop through 500 numbers or 5,000 numbers and get to the password. So essentially, there was zero cost to be able to get through there. And I mean, I can refresh the page, and it's going to bounce around and jitter a little bit, but you're talking essentially 0 to 15 milliseconds, thousandths of a second, to crack the password if it was stored in plain text. So the next thing we're going to do is we're going to come in here and we're going to look at this one. And I changed from PW6 to PW5 when I figured out that everybody does their official testing with that cost thing set to 5. So now we're going to look at this one here, and we're going to say, all right, we're going to loop through, and we're going to see how long will it take us to hack this password if we're going through and we're using password verify, which means now we're trying to actually decrypt this password. So we're going to go through and check, is it 0, is it 1, is it 2, is it 3? And so we're going to go through there and we're going to loop through that, and you'll see the page is spinning a little bit. And again, this is where the whole slow thing comes in. You don't want it to be easy for someone to come in and brute force just hack your way through. Now you'll see, so we went from 100 milliseconds to 8,759. So we're going to say, cost of 5, and I'm going to write on a little spreadsheet here. Cost 5, we're going to say 8,000, let's just round it here, let's see. So 87, we won't round it, 8759. So we're going to take out the 100 milliseconds that it takes to load the page, and we're going to say 8659. Okay. Now, I just realized that when I go to do this with a password strength of 12, it's probably going to be so slow that the that the script is going to time out. So what I'm going to do is I'm actually going to have to go into my Apache server, and I'm going to increase the time that a script is allowed to run. So give me a second. It's still spinning, but just to give you an idea, I walked from my office to my house, which isn't that far, and I went and I got breakfast. I brought it back here, and I ate my breakfast, and I read an article about Phillies fans booing somebody, and it's still going. So I'll keep you posted. And we're back with 1 million, what is that? 1,024,627 milliseconds. So what I've done is I've taken that information and I put it into a spreadsheet. But before we do that, I want to recap. So what we are is we are on the best possible scenario for a hacker hacking on his own machine, with 8 cores to throw at this thing and all that kind of stuff. And it took that long to get to a password of 5,000, which means we took 5,001 guesses. So to look at our chart here, if you see, we had a cost of 5 took 8,600 milliseconds, which is 8.659 seconds, which means that it was able to, at a cost of 5, do 577 guesses per second. We're going to ignore this part for a second. And then at a cost of 12, it was able to do 4.88 guesses per second, which is just insane how much slower that is. And yet, when you log into UserSpice or you log into something that is using bcrypt, you don't even notice it because you only need one guess. And if you fail, even if it takes a full second to do the password, if you fail, you go back there and you re-enter the password and you just don't really notice a second. But yet when you're trying to brute force and trying to go through and guess every single password, you can see that 4.88 guesses per second is going to take a long time. Now, what I've done, and this kind of explains why I chose a cost of 5 for the first test, is I found some people that were trying to use Hashcat, which is something that they use to try to speed up hash guesses with GPUs. And so what they're doing in this one is they've taken 8 1080 GTX cards and are running them on a machine and just trying to brute force bcrypt as fast as possible. And so, when you look at my situation here, you can see that on a normal Ryzen 2700X, I'm getting 4.88 guesses per second. So, on this one, I'm getting 577 guesses per second, which is what they did. And they were able to get 105,700 hashes per second, which is, if you look at my chart here, is 183 times faster. So they were able to throw a lot of hardware, thousands of dollars worth of hardware, and accelerate it 183 times faster than my machine could do. And that's impressive. But when you come back here and look at what would have happened if you would accelerate this one by 100, and again, this is just back of the envelope type of math, if you would expand this one out to where you would do it 183 times faster, that's still less than 900 guesses per second. So what that means is it's not that bcrypt is uncrackable or unbrute forceable, but what I like to say is it's practically unguessable if you use a good password. So what we're going to do, we're going to bring in one more tool, and this is not a perfect tool, and it doesn't really intend to be a perfect tool, but we're going to bring in this thing that Steve Gibson over at GRC did. And basically what happens is he shows you, so if I had a password of 5,000, it's 4 digits, and the search space depth is 10, which means that it knows, most likely if you're going to brute force this, you're going to brute force it with numbers 0 through 9, which is 10 digits, and it's 4, so that the total number of possibilities when you factor that 0 is different than 0000 is 11,110. So if you were able to guess at 1,000 guesses per second, it would take you 11 seconds. And so if you look here, if we were at 8 GTX cards on a cost of 12, I mean, just for the heck of it, you can say that that's 1,000 guesses per second. Like, we'll give them the benefit of the doubt. We'll give them 10% better than what they actually got and say, okay, you can do 1,000 per second. So this gives us an idea that if this were online and you were able to somehow power through with that amount of searching, it would take you roughly 11 seconds to brute force this password. Now, what makes a password, and again, if you were able to do it offline and you could speed it up to 100 billion, which, I mean, again, I can't imagine how many graphics cards or maybe quantum computing or whatever could get you these kind of speeds. But if you could speed it up, this is how long it would take. It would take just fractions of a second at these kind of rates. So what is important about this is really the length of the password and the character space. And so let's do this. Let's not even make the password longer, but let's add a lowercase, an uppercase, and a symbol. So we went from 11 seconds to 22.87 hours by not increasing the password length, but by increasing the character space to 95. And so immediately, now again, if the U.S. government wanted to take an entire building full of GTX 1080 whatever cards, they could, still crack that in less than a second, and that's primarily due to the length, the length of it. So we're gonna so what I'm gonna do, I'll do this. I'll go in here to LastPass, and I'm gonna say generate. Let's see here. How do I do that? Generate secure password. So what I'm going to do, I'll start here and I'll just do a 10, if I can get to 10, let's try 10 character password, and I let it generate it, and I come in here. Now all of a sudden, at a 10 character password, if you were to use the GTX 1080s, you're in the millions of centuries to crack that password. And even if you had 100 trillion guesses per second, it would still take an entire week. So in other words, like if the government wanted to throw all of their resources at it and try to crack it, it would still take them a week to do it. Now let's go ahead and we're going to double that one more time. We're going to come in here and we're going to generate a secure password, and we're going to go to 20 digits, and we're going to refresh, and we're going to paste this. Now you are looking at 1.15 thousand trillion centuries, and you're at a place where even if you had the entire resources of the government trying to crack that thing, you're still in the thousands of trillions of centuries. And so when it comes to passwords, the things that matter are having a good algorithm that is slow on purpose, having a significant cost involved, having a big dictionary, which means that they are a big character set, and having a long password. Now, I do want to show you one other thing that's very interesting. So I know this video is getting up around 20 minutes, so I'm going to try to go quick. One of the things that's interesting is when I am trying to crack this password, you'll notice that whether I'm using the password of 12 or the password of 5, I'm using the same password verify function, which is very, very cool, because that means that over time, as computers get faster, you can allow the thing that creates your passwords, you can change the cost. So you can say, all right, UserSpice, my software uses a cost of 12 by default. You can say, you know what, computers are getting faster. I want to increase that to a cost of 14. I'm willing to spend the extra second or two on people logging in to have a cost of 14. And then all of a sudden, everybody who has the old passwords that has 12, it's smart enough to know, hey, I'm logging in and the strength is 12, and so we're going to get it right. And if it's 14, you can't just change the 4 here. You'd have to rehash the password. But if you make everybody reset their passwords, and then as they log in, they're getting the new cost of 14, then all of a sudden, the people with the old passwords are going to be able to log in, and the people with the new passwords are going to be able to log in, and your system won't break. And so whoever designed this I think it's brilliant. They did a good job. And that's why we use it. So anyway, I know this is a longer video, but I hope you learned something and I hope you enjoyed it. Hit that like button, subscribe button, and thanks for watching.